Welcome to the next video on two-dimensional arrays, and what we're going to show you here is I think it's an example in the textbook that the author starts off discussing. I'm going to hopefully improve on the technique that he uses to get the answer. But what we have here, if you look at the main program, this is just some data that represents the distance between cities. And what we're going to do is we type in the start city, the destination city, and what we're going to do is look up into this table here the distance between those cities and print it out, and that's that. Now, of course, we're not using the template. We probably should use a template, but we're not going to consider the template right now. We're just going to isolate our lecture on what we're doing here in terms of checking for distance. Now, the way you do this technique is, sure, the person's going to type in Boston, all right? And Boston would represent apparently the first row here, because the 0th row would be Chicago. Boston would be the first row, second row, third, fourth, fifth, and sixth rows. There's 7 rows of data in my distance matrix here. Now, to look up the distance between Boston and New York, you go into the second row because Boston is the first row. And then we say New York is the 0, 1, 2. See, New York is the 0, 1, 2, second element of cities. 0, 1, 2 would represent the column of New York. So row 0. So what's going to happen is we triangulate. We say this row, this column. There's 214 miles that separate Boston and New York. Let's see if that's the case. That's the way you look up this data. Run this. I'm going to type in. It's taking its time here. Boston, New York. Enter. 214. Fantastic. Now, that's the way basically. If we ran it again, the distance from New York to Boston would be the same. New York, only this time New York and Boston. We still get the 214. And in this case, when you look it up from New York to Boston, New York being the 0, 1 second element of cities, I'm going to concentrate my efforts in locating the 0, 1 second row of the distance matrix. And then within that row, I look up Boston being for the column. 0, 1 is the Boston element, column 1. So row 2, column 1 is 214. So you see that these are mirror images of the distance matrix. Now there's still a lot wrong with this program, but we're going to fix that in a sec. Like if I type in gibberish for a city and gibberish for a destination, we didn't even handle the situation where we didn't find what we're looking for. So the whole idea behind this program is, first, we type in Boston, but our data is inside a matrix, and the way you index a matrix is with numbers. So what we're going to do is call that code that we talked about earlier in the last chapter in linear search. I want to reuse that code. I'm not going to copy that code into my program. There's no need to. If I go ahead and I include my linear search Silvestri package, I could just use that method. Perfect. Bring it in, and what that will do is return the row index of where we start our search, and then what we're going to do is, for the destination, we're going to do the same thing and look up the column. And the problem here is that gibberish, okay, searching for the cities, that gibberish is obviously not a city at all. That's going to return -1, and you can't index the -1 row or the -1 column, and that's why the program died. There's also another big problem with this program, and that is that, sure, it works, but it's not good enough just for the program to work. The program has to be written in such a way that can be maintained well. The problem with this program is that the data right here and the way you access that data is buried inside the main method. You'd never want that to happen. You want the main method to call a service that's provided by another class. That way there you have a separation of the main method and that service. The main method just calls the public interface of the other class and doesn't have to worry about the details of how to do this lookup. Here's what I'm talking about. Let's go over here. Let me get rid of this bad program. Now the good program is going to use this class here, and we're going to use version 2 here. Okay, version 2. So let me just make sure, pretend you don't see this, pretend you don't see that. We're going to use class 2, okay, the first version, save that, all right. Now here's my main program. My main program basically does the same thing we did before. We prompt for the start and destination, okay. All the details of how to do that lookup is buried within the distance method that's found in this class. See? That's basically what's going to happen. All the details are hidden from the main program. So if I run this, Boston, New York, okay, 214, perfect. If I run it again with gibberish, and we got some illegal cities. Now we've handled the situation where we've handled the situation where we have bogus data, but that's all handled within this method here. See, the main program doesn't care how it gets its work done. Okay, and the nice thing about this situation is this is probably going to be the first program where we actually, in our project, need to have multiple files. And the nice thing about having multiple files is that you can have one person work on the city distance program, another person working on the main program, and all they have to do is agree on the file names that is going to be provided. And at the same time, you can have multiple people working on the program at the same time. You get the job done faster. As opposed to having one big program. See, the problem with one big program is you can't have two people modifying the code at the same time, because whatever one person does will get overwritten by another, and that's not a good situation. So, okay, let's take a look at city distance data. See, the main program is pretty much going to be the same. City distance data. Okay, let's see if we can make that bigger. See, what I'm doing in city distance data is I'm hiding that data. Look at this data is private. Okay, that data is private. It's static. There's only one copy of that data buried inside that class, and people can't access that data. They can't do it. The only thing that they can access is this public distance method, and all that distance method needs to know is what are the start and destination cities. See, and the stuff that we did in the main program in our first introduction is going to call the searching for the indices of those start and destination cities. These return some numbers. If ever there's a problem searching, we're going to throw an exception. Remember, when we throw an exception, an object gets thrown and someone has to catch it, and I believe the main program catches it by simply outputting the message. So here's what we do. We create I'm going to talk about exceptions in much more detail, but if there's a problem, you see we have row is equal to -1, don't even think about trying to access that data with a -1 index. What we're going to do is throw an exception. Execution basically stops, and that thrown exception gets caught in an upper level method right here. And like in the main method, right for now, all we're going to do is just print out the message. If execution comes here, you've got some valid indices. You can now access safely the data that's inside this matrix, and That's great. That's good. Now, I wanted to show you, I wanted to make sure that my columns are nice and aligned here. And if ever you do a format on this code, you're going to lose that formatting. So what I wanted to do is tell the Eclipse here to stop the formatting and then restart the formatting, because I want that data to be formatted the way I want it in the file. And then I show you how to enable that feature here. So you could go ahead. This has nothing to do with the actual logic. This is more an Eclipse issue. So take a look at that. Now, great, it works. We've seen that it works. And what we're going to do now is stop the video for you, so to give you a time to digest what we've done. And then I'm going to continue with another video for more advanced features. Now I want you to think about, how can you improve this program? Okay, how can you improve this program? We'll see how we can do that in the next video. Bye.